Okay, guys, thank you so much for coming today. So today we're going to do a review session for midterm 1, and we're gonna do all the 5 lectures we've done so far. We just do one in turn, and then I'm gonna also describe the exam format, which most of you are familiar with, and you know, the quiz will be due a day before the exam, and it should be live today.
Is the quiz still 50 questions?
Yeah, it's going to be 30 questions.
30?
Yes.
It used to be 50 though, right?
It used to be 50, yeah. And I will, talk about the format for your exam. It's slightly different from AMP 1, but it's more or less the same things. So before we do lecture 1, the tissues, membranes, and glands, I'll just do the exam format. Okay, so we're going to have section 1 is our usual multiple choice, and it's going to be 25 times 1, which is 25. And section 2, it's going to be definitions. For instance, I would say accommodation. You know, they define accommodation, or sensation, or perception, things like that. Okay, and that would be 5 of 6 times 2, which is 10. And then section 3 will be the short answer questions that we're used to already. It will be 5 again of 6 times 2, which is 10, and section 4, which is the long answer. I think we'll do 4 of 5 times 5, which is 20, which makes 20, 30, 40, 65. So your exams will probably midterms that is range from about 60 to 65, 60 to 65 points, and that's how much this will be worth in terms of your points, because we'll be doing the point system. Okay, if the quiz is 30 questions, so it's 30 points. So it's kind of worth half of the midterm in terms of weighting.
The quiz.
Yeah, because it's gonna be, your grade is going to be based on a point system. Like the less math modules are 5 points each. So that's how much. It will be 5 out of the total of all the points will be the weighting for that activity. See what I'm saying?
Do we still have the opportunity to retake a test?
Yeah, you still have the opportunity to retake a test, and I only give you opportunity to retake it at midterm 1 or 2, so that by the time you get to midterm 3, you should be used to the format, and you should now be kind of sort of cruising, if you will. And by then we'll be heading towards end of term, and we don't want you getting bogged down with past exams and so forth. So that's why I give you a chance to retake either one or the second one of the midterms. Okay, so I'll just go through this, and I'll kind of tell you what kind of questions the information kind of lends itself to, and so forth and so forth, so that you are prepared. So of course, these are some of the things that will come up in the definitions. What is the definition of sensation? What is sensation?
The ability to perceive stimuli.
Yeah, but you feel a sensation when what actually happens in your brain. When when your brain actually acknowledges the sensation. That's the stimulus. When your brain becomes aware of the stimulus. That's what I'm saying. That's when it becomes a sensation. If the receptors pick it up and your brain is not aware of it, you won't feel it. You know what I'm saying? If it's not conducted. So a sensation is actually when your brain becomes aware of the stimulus. All right. So a way of stimulus. Okay, so that's those. When you have a definition, of course, you have a full definition for it, and then perception is talks about how the brain actually processes that sensation. Okay, processes the information it has received. What's that?
1 to 5.
Yeah, lectures 1 to 5. It's a review session of all the lectures we've done so far for midterm 1. Yeah. We're not so that's the thing. So perception is actually how processing. For short, I would just say stimulus. Okay, processing stimulus. Okay, when your brain actually sends it to maybe the association center, and that information is processed. Perception may differ between individuals. How you perceive a certain stimuli, it may be different. You see? So perception is more individual than, because the same stimuli, we don't all see it the same way. Sensation requires, so when you define these things, you have to mention those things. You have to, talk about, what that process includes. So we get the general senses, right, and the special senses, okay? Sensation requirements, of course, it's just like the mechanism of a homeostatic, mechanisms, the steps, like the receptors pick up the information, and then it has to be conducted through sensory nerves to the brain, and then the brain has to process it, all right? And then the brain, usually, if a nature is required, then for that sensation to respond to that particular sensation, then something will be done via the effectors. So those steps, and you can go through those steps in your book, okay? So again, this is a kind of 5-point question, where I could ask about, sensation and how it's processed and what steps need to occur. You know what I'm saying? And it's in your notes, and you can go through that. And then sensation, senses with the general senses. Okay, and somatic and visceral, right? All right. Visceral senses, what are the visceral senses? 2 of them, right? Visceral senses, pain. Okay. And then somatic, there's like 5 of them, Those are special senses. Yeah. This somatic sense is what your muscles and your skin is, general, like touch, pressure, pain, temperature, those things, is 5 of them. Okay? All right. And then now you can chime in there, Jessica. Special senses we have. So these are confined to the head, sight, smell, taste. What else? Hearing. And what's the last one? Yeah, balance. You see? And we will do smell and taste in this lecture, and then we will do sight and hearing in the next 2 lectures. Right? And then we'll go through all those parts of those special organs. And then, of course, you got to know the definitions of these types of receptors. Okay? These are just general types of receptors, right? We all know what nociceptors do, right? What are nociceptors? Pain receptors, okay? And what's the function of pain receptors? Yeah, to limit tissue damage. You know what I'm saying? Because if you didn't feel pain, you could be hurting yourself, your thing is bending up or whatever, your hand, and before you know it, it's just a stump, and you have no hand. So, pain receptors, pain, okay, mechanoreceptors.
Proprioception.
Yeah, proprioception, the response to mechanical forces. Okay. Okay, and then we'll talk about some mechanoreceptors and functions of them. And then photoreceptors, this is eye, of course, right? Sensitive to light. and we'll talk about them in the I one. Chemoreceptors, what are they sensitive to? What's that? Yeah, you've given me examples of chemoreceptors, but by definition, what does a chemoreceptor do? What is it sensitive to? What's that? Yeah, chemical concentration. Okay, chemical concentration, because it has to be dissolved in solution. So you've got to, if you say responsible to chemicals, it's kind of like partial points. Okay, it doesn't quite say what it does. It's actually responsive to concentrations. So if the concentration is different, then that receptor is stimulated. See what I'm saying? Concentration differences. It's not the chemical in the in the solution per se that's causing the stimulus. It's the change in the concentration of the chemical. Okay. So if I ever ask about these receptors, you kind of have to explain it like that, so that you can show me that you understand what that receptor is sensitive to. All right? Okay. And then thermoreceptors are very, just like the name says, temperature, right? And this is my shortcut for temperature, right? And this is my shortcut for concentration. So you have to talk about that cork. You see what I'm saying? So you got to talk about that. All right. So of course this would be like a 5-point question, where you'll be explaining these general types of receptors. Right. So what is the receptor by definition? What is it? It's a specialized cell or nerve ending that is capable of
receiving.
Yeah, responding to stimuli or to changes. You see what I'm saying? So you gotta do that. You gotta know. And then general sense receptors. There will be free nerve endings. These are just nerve endings that are free, and they're responsible for any kind of touch, like itching and so forth. Right? Light touch, free nerve endings. But then there are specialized touch receptors. There's 5 of them. Okay. So you gotta be careful in the exam. When I'm asking about the general types of receptors, where you start chiming in with photoreceptors, chemoreceptors, mechanoreceptors, and things like that. But if I say touch receptors, then you're not going to be talking about photoreceptors and stuff like that. You're going to be talking about different types of touch receptors, where you say Meckel discs, right? Okay, hair follicle receptors. Okay, Ruffini end organs, Meissner corpuscles, all right, and Pacinian corpuscles. These are different kinds of touch receptors with different kind of sensitivity to touch, right? So Meckel discs, first of all, where are these located in the skin? The layers. Yeah, it's more superficial. So it's in the which layer of the skin?
Top
layer. Yeah, which is
dermal layer.
Epidermis. Epi on the top of the dermal. So it's in the epidermis. If I ask about these touch receptors, you need to be telling me where they are located and what they do. Okay, so Meckel receptors are in the epi, right? Epiderm for epidermis, and then they. What do they do? What are they sensitive to? Light touch. Okay. To get a full point, you need to talk about both of those things. Hair follicle receptors. I mean, the name tells you where they are, right? If you get that one wrong, shame on you. Okay. These are wound around, the hair follicles. Okay. So they respond to, when the hair is bent. You know what I'm saying? If you're hairy, like myself, I can put my hand over it, over my skin, and I can feel it because the hairs will be bending and I can feel it. Okay? So, you know where that's at, and hair bending, okay? When the hair bends, it generates an action potential. Meissner corpuscles. Where are these located? It's in the epidermis, but where in the epidermis? So like in the basal layer, okay? That's what I'm saying? Kind of the deep layers of the epidermis. Okay, and then what do they do? The touch receptors there, that's a start. I've already kind of told you that. So what kind of touch?
Tactile sensation.
2-point discrimination. 2-point discrimination. Okay. You want to say that if you're going to talk about this, you need to talk about being in the basal layer or the deep layer of the epidermis, and you need to talk about 2-point discrimination. To get a full point for that, description, okay? So it's 2-point discrimination. So it's like kind of like when you're touching 2 parts of the skin, 2 points of the skin simultaneously. It's able to really, I mean, many psychopaths do that. They're able to say, okay, your skin is being tight here and there. Okay? So, Ruffini end organs, where they're located in the first place. Oh my God, this is good. Where are they located? We're getting deeper as you can realize. We're getting deeper and deeper and deeper.
Tissue.
No,
Oh, no.
no.
Yeah.
It's the dermis, right? So the deeper we get, what do you think is happening to the stimulus? Is it getting smaller or is it getting bigger?
Bigger.
It's getting much bigger, okay? Because if you were to have a lot of sensitivity to some of these receptors on the top, they would be just overstimulated if you were to apply deep, if they were sensitive to deep pressure. See what I'm saying? So Ruffini end organs, we said they're located in the dermis. So what kind of, what are they sensitive to?
Deep pressure.
Yeah, deep pressure, yeah, and it's continuous pressure. It's continuous touch. So this is some degree of magnitude, right? Because it's continuous, it's not ceasing. Okay, so it's deeper. Okay, so continuous. So I'm gonna probably ask about these ones because they seem to be like a good question. And yeah, you tell me where they're located and what they're sensitive to. You know what I'm saying? Touch receptors. Doesn't it make a nice 5-point question? Yeah, it does. Pacinian corpuscles. P for pressure, right? So these ones are sensitive to?
Pressure, vibration.
Yeah,
Pressure.
deep pressure, heavy vibrations. And of course, they're located in the Cassie, you said it in the beginning. Where are these ones located? The
Subcutaneous tissue.
Yeah, the subcutaneous tissue, very deep, just deeper, just at the bottom, of the epidermis there. So these are really subcutaneous tissue, and it's vibrations and heavy pressure. You know what I'm saying? So gotta know these guys, where they're located and what kind of, what they're sensitive to, because that forms an. And then, of course, the proprioceptors. And where would you find most of these proprioceptors? Where? In which organs of the body?
Obi tendon.
That's an example of a proprioceptor, but in which organs of the body would you find proprioceptors?
Skeletal muscle.
Your men?
Yeah, skeletal muscle. And what else?
Joints.
Tendons. Yeah. So tendons, muscles. Okay. What are proprioceptors anyway?
How does your body be aware of itself in space?
Yeah, awareness of body parts in space, where they are. That's why I can close my eyes and I can touch my butt, I can touch my nose, I can touch anything without looking. Because that's why they make you do that, because that being drunk impairs your proprioceptors. It impairs most of your senses anyway. Okay, so that's why they make you touch your nose and stand on one leg and do this and that and so forth. Okay, so good. I'm sure some of you have taken that test before. No, not me.
I did and passed.
Oh, so that was good. You did good. You should do the same for this exam, okay?
I hope so. I think touching my nose is a little easier.
Yeah, I know. I'm sure you can touch your nose anytime.
Even if I'm drunk.
Of course. Yeah, that's an easy test. I'll try and make this one user-friendly too for you. Proprioceptors, functions, we just talked about it, right? We know what they do, okay? Sense of awareness of body parts, movements and so forth, right? What are the other, functions of proprioceptors? Like, there's like 4 of them. Weight, yeah, determination of weight, okay? Okay. What about joints, in terms of joints, what are the things? Like range of motion, right? Okay. Range of motion, proprioceptors,
Range of motions that
and movement of a
Without
joint. Like
making
how
it-
far you can stretch your joint.
Sure.
Gymnasts have higher range of motion. What's that?
overextension, stuff like that.
Yeah, to stop you from overextending and over, stretching your muscles, because you may just tear a tendon from the bone. That is rate of movement and so forth. Okay, so look up those functions. Okay, guys. For sometimes 2 points. Okay, what are the functions of proprioceptors? And then you mention 2 of them. Then I say, okay, what's the third one or something, and you get another bonus point. That's another thing in the exam as usual. We have bonus points sprinkled all over these things. Okay, so you have the ability to get more than 100%. Yeah.
That's funny.
Well, it shouldn't be. It should be fact. Okay, so we get, we already said they are located in muscles, these proprioceptors, and they're located in tendons. So we get to what? The ones located in muscles are called muscle spindles. The ones in the tendons, Golgi tendon organs. Okay, and what else? Is there also a proprioceptor? Like I said, encopassums, inferior ventricles. 4 of them. All right, because this is heavy pressure and tension, so that's why they are also involved. Okay, so gotta know those proprioceptors, gotta know the functions of proprioceptors. Well, you know what they serve the function of, like weight, determination, and things like that. All right, so now we come to the fun part. This sensory tracts going up, and then we'll talk about the ones going down. Okay, sensory tracts. Okay, the ascending pathways. What do they provide? Information about.
Body to the brain.
Sensory information to the brain, okay? Mostly to do with the skin, right? And touch and receptors, so cutaneous information, all right? Like the anterolateral system, if I was to ask you to define it, anterolateral, some of it is said in the name, okay? And whenever I ask you to mention some of these things, like in the definitions, if I say anterolateral system, you have to mention 2 solid points about it. And one of the points is that it's located where in the spinal cord? Anterior and to the side. That's where you find those tracts located in the spine. You know what I'm saying? Okay? Okay, so there will be, so this is the anterior. Well, actually, this is the posterior, it looks like. And this is the anterior. So this will be kind of located around here. See what I'm saying? Those tracts. And what do they do? They send sensory information about which organ? The largest organ in the body. Your skin, cutaneous. They send information, sensory information about your skin. So you're going to be involving a whole bunch of these. What kind of receptors? What kind of receptors are you going to be involving? If you're sending information about your skin, what kind of receptors?
General.
Like touch receptors, for instance, you know what I'm saying? All those medical stuff we've been talking about. Continuous pressure, things like that. Yeah. Okay, so it's touch. You know what I'm saying? Mostly touch. Okay, and so there's 3 of them. And I talked about this is the origin and this is the termination, right? So if I was to ask you to mention a few of these anterolateral system tracts, and you say spinothalamic, then it will start in the spine and end up in the thalamus, right? Okay. And this one is about all those touch receptors we talked about. So I want you to mention things like the medial disc, the touch, the pain, the temperature, of course, for this one. And then spinal reticular, it ends up in the reticulum formation, okay, in the brainstem, which arouses yourself into a state of wakefulness. So this would be unconscious pain, okay? So if I ask about the systems, you need to tell me what it's doing, okay, where it's starting and where it's ending, okay, and what is the purpose. And then you might want to throw in a couple of receptors that are involved for that. Okay, because you know the receptors, you know all the touch receptors, you know all the general kinds of receptors, you know that. Okay, you should be able to associate that. So here we'll be talking medial discs, all those things. Chemoreceptors, because it's all this. Look up your notes, you'll see that. And then this one, reticular formation in the reticular formation. In the brainstem, BS, brainstem, not BS, but brainstem. Okay, and then unconscious pain, so nociceptors. And this one, spinal mesencephalic, it ends in the midbrain. Mesencephalic is middle, cephalic of the head, midbrain. It ends in the midbrain, starts in the spine, midbrain, and then it's unconscious what and what? A pain and touch, very good. Yeah. Okay, so and then there's the dorsal lemniscal system, okay, and then the trigeminothalamic tract, and this is talking about the trigeminal nerve, so the face, information, teeth, sensory information about that. All of the thing about the trigeminal nerve here. And then spinocerebellar, it's about balance because it goes to the cerebellum, which is involved in fine motor movements and so forth. All right? Okay, so just know these systems, and then of course cerebral cortex, sensory areas. Okay, where's the sensory area for the, where is it located in the cortex? Before the gyrus, central gyrus, or after the central gyrus? So I gave you a choice of two. Before or after? It's like heads and tails. Before or after the central sulcus, the one that goes across like that. Sensory is? That's what we've been looking. What did you not? Taking a gun. Okay. Okay, there are areas in the brain, in the lobes of the brain, like the frontal parietal, and they're specialized in this particular action. Like I'm asking where the area specialized in sensory information is located. And I gave you two choices. The pre-central gyrus or post-central gyrus. You see, the brain is kind of like this, you know what I'm saying? And then the cerebellum, the brain stem. Okay, so here would be the central gyrus, okay? Central sulcus, sorry. Sulcus. Okay? Central. And then there's an area specialized for something here and an area specialized for something there. So this area will be the pre-central gyrus because this is the frontal cortex, right? Pre-central gyrus, and this is the area called the post-central gyrus. Post-central sulcus because it's the bulb. Okay. So sensory is located here or there is my question. Pre-central or post-central?
I say pre. Okay, close.
That's the other one. I mean, default. Pre is motor, okay, guys? Did you see those lines crossing on the thing in there? Yeah. Gotta know that, guys. All right?
Pre or post?
It's post. Yeah, it's after it's
Yeah.
Yeah. So which lobe is it located in? Yeah, it's in the parietal. And then the other one, which we'll be talking about in a little bit, is in the frontal. It's in the frontal lobe. Okay? So know that. So this one is in the parietal lobe, and it's post-central sulcus. All right. All right. Very good, guys. Are you tired yet? Or you just start? So we know that there's, for motor now, we're going down now. Okay, we went up, now we're going down. So there's two neurons here. One's, lower motor neurons, who kind of sort of start in the brainstem or the spine going down. And then there's upper motor neurons, which kind of start in the cerebral cortex, in the cerebellum, and then come down a little bit to the brainstem for the most part, or sometimes to the spinal cord. Okay? All right. And we know that the upper motor neurons, because the upper motor neurons are actually right in the brain, inside. They are connected to lower motor neurons via two ways, which are? What are the two ways that upper motor neurons are connected to lower motor neurons? Direct and indirect. Okay? Yeah. Nice. So the direct ones, they synapse directly with lower motor neurons. Okay, there's no interneuron in between. Okay, but the indirect ones, they go to some brain nuclei, say maybe the red nuclei. That's why you have the rubrospinal. Okay, and then interneurons will take the information to the, so it will synapse with another neuron that finally connects with the lower motor neuron. See what I'm saying? Usually it will pass by some nucleus that does something that is specialized with that particular, information being sent to the muscles or the organs or the effectors. Okay, so there's ones that go into red nucleus. That's why the rubro is red, and then reticulospinal, in the medulla oblongata there, in the brainstem, where you have the reticular formation, okay, and then the vestibular spinal, which is the vestibular nuclei of the brainstem of the medulla oblongata, which has to do with what? Vestibular, we've heard about it, right? It carries what kind of senses, what kind of special sense? Balance, right? Remember the vestibulocochlear nerve, which we'll be doing in a little bit after the ear. So it's got to do with balance and stuff. You see what I'm saying? So the good thing about these tracks is that the name kind of tells you a little bit about it. You know what I'm saying? It kind of says a little bit about it. Okay, so rubrospinals. So I want you to know about lower and upper motor neurons. I want you to know the two ways by which the upper motor neurons are connected to the lower motor neurons. Okay, and then just be able to give me an example of the indirect ones and the direct ones, which we'll talk about in a bit. And then cerebral cortex motor area. So this one will be located pre-central sulcus, right? So it's before, so it's located in the frontal lobe, right? So frontal lobe of the brain, okay, and that's the area that deals with motor information.
Prefrontal lobe, is that what you said?
Pre-central sulcus. Yeah. Okay. So there's a groove that runs in the center that's separating the frontal lobe from the parietal lobe. That's what we're calling the pre-central sulcus. Okay. So know the location of the motor, location of the sensory areas, and which lobe of the brain it is. Okay. Yeah. And then, of course, for speech, we get two areas. Because these ones I'm sprinkling the definitions. You know what I'm saying? I'll throw it in the definition and say, okay, what is Wernicke said? What is Wernicke said? Yeah, I kind of told you about it. Speech, okay. But how is it involved in speech? Wernicke. What kind of area is it also? Is it?
Comprehension.
Well, yeah, it does comprehension, word choice, comprehension of words. Okay, but what kind of, Wernicke, W, word choice. No, that's what I always come up with. And it, word choice, and it's a kind of, it's like a sensory area, you know what I'm saying? It's like a sensory area, all right? Kind of borderline with an association area as well, because it kind of sort of processes the information. And then it's connected, of course, to this Broca's area, okay, by the fasciculus something. It's in your notes in there. Okay, it's an association area that connects the two. And then this Broca's area, what does it do? Yeah, it's a motor speech area. And what does it do? It's motor, so that means it controls muscles involved in speech. Mm-hmm. That's what I'm saying. So gotta be able to tell me about these two areas. What kind of area is it? What is its function? Then you get a full point or 2 points. Okay. Speech muscles. Okay, guys. Okay, very good. And these are usually located on which sides? The right or the left hemisphere? Or are they located on both sides? It's the left, usually the left. And it's only on the left. It's not on the right. Okay? So if your right lobe is injured, you may probably not have problems with speech and so forth. But if your left lobe is injured, you may have speech impairment and so forth, or slurred speech. So it's on the left side.
So stroke victims have problems with this.
Yeah, stroke victims who happen to have a stroke on the left side, they might be having slurred speech. Yeah. But if it was on the right, then we'd be okay with that. Speech will be
I
fine.
didn't have to stroke when I was 30.
Yeah. Oh, that's bad.
Yeah. I had to relearn everything.
Yeah.
She can talk a lot
For a long time, yeah.
She still has problems.
Just like the one I also was given an example of is Gabby Giffords when she was shot in the head. She can't let you relate some of these other things.
This one had a stroke because of a heart valve
Heart valve.
defect, and an infection sat on that heart valve from Delaware.
Yeah, exactly. Yeah.
She got a lot of money out of it because the doctor didn't diagnose her right.
Yeah.
If she'd known about it, it wouldn't have happened.
Yeah. But a lot of money doesn't kind of sort
No,
of,
it doesn't make it better.
Yeah. But yeah, it's too bad. Yeah, those things happen because again, those nerves that pass through there, you know, and they're all connected. Some of the nerves to go to the front, you know, like the chordae tympani. You know what I'm saying? It's actually a facial nerve for taste. The front 2/3 of your tongue, but it passes through the ear. So when you have an ear infection, sometimes you know, and if it's, you know, your taste may be funny. What does
My friend had fell out of the car.
Yeah.
And he lost the sense of smell, so everything tasted weird.
Yeah, because remember, we're going to talk about it in a few actually. Taste and smell are really associated together. Most of the time, if you get a cold, that's why we talked about last time, we said things taste bland because your sense of smell is messed up.
The chocolate tasted horrible.
Ooh, chocolate is bland. But if you taste horrible, then you get problems. You see, with the taste. So, 5 special senses, we talked about them: smell, touch, smell, taste, not touch, sight, hearing, and balance, right? So we know about the 5, okay? And then sense of smell, of course, and then we'll do sense of taste and finish this lecture. So we get bipolar neurons, okay, for the sense of smell, and bipolar have got 2 processes, right? 2 processes. Remember from ANP1 when we did bipolar, unipolar, and multipolar neurons, guys? And we said bipolar tend to be in the special senses. This is why. This is what we meant. Okay? And what kind of receptors are they? Chemoreceptors, so that means they're sensitive to concentration changes. So when you smell, take it through your nose, because when you breathe in, anyway, the air is sprinkled with a fine mist of droplets to make the air moist. And when that happens, all the chemicals for smell will be dissolved in that fine mist, and that's how you're able to smell it. All right? And then, of course, it stimulates the G proteins. Okay? Once those, the hair cells are on the bipolar neurons, you know, they stimulate G proteins. Okay? And you know about the G proteins, right? Those alpha subunits. And then olfaction neuronal pathways. Okay? Just goes to the medulla, and then sense of smell doesn't go to the thalamus. It's the only one that doesn't. Okay, so you've got the nerves, then you've got the bulb, right? The olfactory bulb, you know, that is usually cut off when we do the brain, you know. And then the tracts will be the interneurons form the tracts because they will be in the central nervous system. And then those tracts go to the you know, olfactory cortex. Okay? So, those neuronal pathways, and of course, taste. They're the taste buds, right? Taste buds are about 50 cells together, 50 taste cells in there. And there's 4 types, right? And one of the types doesn't have, and is the most numerous. It doesn't have taste, it doesn't include taste buds. It just increases what? What does it do to the tongue, to the texture of the tongue? It just makes it rough. Yeah, it makes it rough so that you're able to manipulate food in your mouth. If the tongue was slick and not rough, you cannot roll and manipulate a bolus of food, especially when it's all mucused up with saliva. Yeah, you gotta mix it with saliva. It's kind of gross, but it really has to mix up, you know. Even if you're gonna taste it, it has to be mixed up. So the tongue is rough because of that 4th type of, you know, it's not really a taste bud, but it's just gives texture. And then the other 3, of course, is just shape, top shape. But they've got 3 types of cells, right? They got one that starts with a B, these taste buds. basilar cells around the base, and then cells that kind of do what now? Support cells. Okay, because I want you to be able to tell me about the taste bud and the kind of cells they are. Support cells that are supporting the taste cells. Okay? Yeah. All right, guys. Very good. So gotta know the taste buds, okay? And the three cells. Okay? Support cells, basilar cells, and then taste cells. Okay, hair cells that actually they have a pore in the middle, and then that's how you are able to, taste. And then of course, taste, neuronal pathways, goes through the medulla, goes through the thalamus this time, okay? And then goes to the gustatory cortex, right? So you look up these pathways, you can see that. But if you ever talk about neuronal pathways for smell, do not include the thalamus, okay? Okay, now lecture 2. We got a 2. These ones will go a little faster now. Okay. So the eye, which is the eyeball and the optic nerve, that's what forms the eye. Okay, the eyeball and the optic nerve. So I'm going to say ball, optic nerve, and then accessory structures. We got eyebrows, eyelashes, conjunctiva, lacrimal apparatus, right? And then the extrinsic eye muscles, the ones that move the eyeball. So, note the functions of all these guys, right? The eyebrows, the function is to prevent sweat from getting into you when it's rolling down your brow. And then eyelashes also prevent particulate matter and so forth, dust getting in there, all right? And then eyelids, lubricate the eye, spread the tears around, and they got 5 tissue layers, skin on the outside. Okay, spit it out, guys. Skin, then loose connective tissue, thank you. And then what? Muscle layer, because like the orbicularis oculi, elevator papillary superioris, and then the. Yeah, I might say, can you tell me the 5 tissues and what they are made up of? You know what I'm saying? That's a good question. You reminded me of that. It's a 5-point question. Okay, and then what's the other one after that? Yeah, and it's called dense connective tissue or tarsal plate. Okay, tarsal plate, right? Tarsal plate. And in it is the tarsal gland, right? What does the tarsal gland do? What does it do? It creates a waxy solution that coats the eyelids so that what doesn't happen? Yeah, you don't tear because you're constantly producing tears to wet your eye. If you didn't have that kind of waxy layer on the, right on the tip of your, almost like eyeliner, you know what I'm saying? Like you ladies, you know about that. But that is kind of inside, and it will prevent your tears from always, otherwise you just be crying the whole time, you know what I'm saying? Because the tears will be coming in. So the wax will stop it. Okay? And then there are the ciliary glands that form an oil that does what? That are interspersed between the hair follicles of the eyelashes.
Makes the eyelashes soft.
Yeah, oil, to make, how ladies put oil on your hair, you know what I'm saying, to make it nice and soft, otherwise you get brittle and you get ends and whatnot, I don't know. You see, so you put oil on it to prevent all that. Same thing, if your tears, your lashes are brittle and they're not thingy, they're not nice and soft, they're not going to be nice and curved, and you know what I'm saying? They'll be frizzy, and they'll just break up and make you eye all the time. Okay? So that's that, and then the final layer is called the the conjunctiva. And what kind of tissue is that? Conjunctiva is it's a mucous membrane. It's a mucous membrane. Yeah, guys, you gotta know the tissues that make up these layers. Okay? Yeah. Okay, thanks, guys. Okay, and so that's them, and then the lacrimal apparatus, you know what they do, produce the tears, of course, and you know what's in the tears, right? Things like lysozyme, all those enzymes, and so forth, kill bacteria, you know, and mucus, of course, to lubricate, right? But it's mostly aqueous, right? There's a lot of water in there, okay? So knowing what tears are made up of, and of course how the lacrimal apparatus is arranged, and how it dumps into the nose. It's kind of like an over drain, you know. It's like an overflow. Yes, very good. Overflow. That's what it is. Okay, and then we know what the extrinsic eye muscles do. You know, move the eyeball. What do the extrinsic eye muscles allow you to do about your vision? What do they allow you to do? Yeah, to do that. When you do that, what are you usually doing? Tracking and a moving object. Very important, don't you think? Like, you know, when you're shooting, sometimes you go and then you have to follow that. If you didn't have those eye muscles, you won't be able to follow and shoot a target. Yeah.
Also helps with sarcasm.
You have to be moving your whole head. Imagine, you know, and you run out of, you know, you can't. Then you have to move your whole body.
What about people that have lazy eye? Like
Yeah, lazy eyes. People, one of the muscles is lazy.
Oh,
it's kind of, yeah. So it's kind of drooping the eye a little bit, like so.
Crazy to look at the eye.
Crazy eyes.
Yeah. Okay. So lazy eye is prevented by those guys, extrinsic eye muscles, and then sensory neurons. Of course, you need that to take the information, you know, through the optic nerve. Okay. And then we get everything's kind of very detailed all the time. Okay, fibrous layer is those two. What are they? Sclera and cornea. And there's a lot of things you need to know about each of those. You know what the sclera is, what it does. Okay, the functions of the sclera, like maintain the shape of the eyeball. Those things are very important. Protect. Okay, the cornea. What is the kind of the major function of the cornea?
Receives light.
To do what now? To refract the light. What did you say?
That's that receives light.
Yeah, it receives light. Yeah, but really, because it's the major light refraction organ of the eye. Not even the lens is the major light refraction. You know what I'm saying? It is the cornea that does that. So the major function of the cornea is to bend light, which is refraction. Okay, so the vascular layer has got those three layers. The choroid cord. My handwriting is going to be a little funky, okay, because I'm trying to go fast so I can finish. The choroid cord, okay, the iris and the ciliary body, okay, and the ciliary body, CB, not Chris Brown, ciliary body, all right. So the nervous layer is got mostly the retina, right, and you need to know the functions of all those and so forth and so forth. And then internal cavity has fluids, okay, you know. So we got the vitreous at the back, and then the aqueous at the front, and we got three chambers, right? The anterior chamber, and then the posterior chamber, which is behind the iris but in front of the lens. I know it's not really back, but that's how it's divided, okay? And I didn't do that. And then the vitreous chamber is right at the back, with the gel. Yeah. So know those three chambers, okay, guys? There's three, not two. Yeah, very good. So know about that. So I gotta sort of get a move on here. And then of course characteristics of the lens, which are what? Biconvex, transparent, no blood vessels, and it's got the crystalline proteins, which makes it transparent. Okay, crystalline. So gotta know all those. And then of course the function of the lens is to fine tune the refraction of the light. Okay. And it's involved in accommodation. What is accommodation? Maybe the definitions, you know what I'm saying? Changing lens shape to view objects, okay? So that are then all those words and definitions. And then of course the visible spectrum is what the eye can see. Refraction is bending light. Focusing system of the eye, all right? That's the lens. You know, because it fine tunes the focus to focus light onto the macular artery, right at the focus and tracks. Distant and near vision, right? So distant vision is 20 feet and beyond. What is distant vision? 20 feet and beyond. Near vision is before, okay? And then near vision, that's when you have to do, you know, accommodation, okay? and the lens has to change shape for that. And then there's also the near point of vision, okay, which is the nearest distance the object can be for you before it goes out of focus. Because if you keep bringing it towards the eye, it will go out of focus. And as you get older, because your lens becomes very tough and not elastic, and your lens cannot change shape and accommodate, your near point of vision goes further and further and further. Okay? And you need to know about the emmetropic eye as well. Right? Remember, what's the emmetropic eye? Is the natural condition of the eye, right? When the lens is not doing anything. When it doesn't have to do anything for you to view objects. So it's 20 feet normally for the normal person. It's 20 feet away. Your lens is in its natural flat position. Because the ciliary muscles are, relaxed. You see what I'm saying? Mm-hmm. So know about the emmetropic eye. Be able to define it, okay? Good. All right, so good. And then, so all these things that needs to happen when you're focusing an object that's near, you gotta accommodate, and the pupil has to constrict. You notice when you're bringing it closer, your pupils constrict, and then of course your eyes converge. They come together like this. Those are the eye muscles. So sometimes I might say, what are the three things that happen when you're focusing, near vision objects less than 20 feet? Okay, rods and cones. All right, rods. They have the rhodopsin protein, which is made up of two proteins called opsin and retinal. Okay.
Retinal A, right?
Mm-hmm. Retinal and opsin, and then retinal is a protein that is inside of opsin to form rhodopsin, and that's when it's in the dark conditions. Light actually activates rhodopsin so that the retinal will separate. I need you to know that cycle. The rhodopsin cycle, you know what I'm saying? What happens when light activates rhodopsin and the retinal changes shape, gets out of there, and they dissociate. So you have separate opsin and separate, retinal. All right, and then you need energy to change the retinal back to the original shape so that it can reassociate with opsin. That's why when you are moving from dark to light conditions, you have a time of
Blindness.
yeah, momentary, because you'll be trying to change in the cycle. So you need to know that cycle. I may ask about that. 5 points, okay? And then 6 for the, for the last point. So know about that. And then of course the cones have these 3 pigments: the red, blue, and green, cyanolab, erythrolab, and so those are the 3. Okay, so know about the cones and their sensitivity to light. Okay, bipolar and ganglion cells, of course, are connected, and the ganglion cells, okay, are the neurons in the optic nerve. All right, and then of course the neuronal pathways for vision, right? Goes through the thalamus. Of course, depth perception. We use binocular vision, right? The binocular vision is the part of the object that both eyes see. Okay, there's parts of an object that only the other eye sees. Monocular vision. So binocular vision allows you depth perception, distance the object is away from you, and stuff like that. So be able to define those things. Those are things that would sprinkle in the, you know what I'm saying? Yeah. Hearing and balance, number 3. Oh, great. Everything is split to 3. External ear is including the auricle and the external acoustic meters. Yeah, external acoustic meters and the tympanic membrane, right? The tympanic membrane is the junction, is the end of the external ear. So we know the parts of that, and then the middle ear. Yeah, the Menes, Malleus, Incus, and Stapes in that order. And then the bony space in the temporal bone, we know that. And then of course the inner ear. It's got 3 parts again. It's got the cochlea. Okay. So the cochlea. Okay. Semicircular canals, guys. Parts of the semicircular canals. What else? else? Starts with a V. Vestibules. Yeah. Okay. So what is the cochlea involved in? Hearing or balance?
Balance.
No, that's hearing. Okay, is it hearing?
It's hearing.
The semicircular.
Yeah. So guys, cochlea is for hearing, okay guys? What kind of hair cell is in there?
Um,
Starts with an O.
I know. Hold on, I can.
OS if you like. The spiral organ or the organ of Corti. Guys, should we take these things? Oh,
It's
okay.
Monday, give us a break.
It's Monday for me too, by the way, you know what I'm saying?
Yeah, but it's all like entrapped in your brain.
It's incredible. I managed to trap it, eh?
Yeah.
I want you to do the same. Semicircular canals, those three on the XYZ plane. And what kind of function for that? It is
Balance.
what kind of balance?
Snap.
Saturn.
It's the other one. So it's dynamic balance. And then vestibule, static balance. Okay?
That's balance.
Whew, guys. Oh, I got it. And then you gotta know these things: pitch, volume, timbre. Okay? Pitch is the frequency, right? Higher frequency, higher pitch, low frequency, low pitch sound. Okay? And then volume is what of the wave? Yeah, which is the amplitude. If you say height, I might just give you a point and look away, but you should say amplitude, okay? Amplitude is the size of that. You know, how high it goes and, you know. And then timbre, what is timbre? Yeah, resonant qualities of sound. Okay, it's kind of gives tone to it, kind of involves the sinuses and so forth, and how the sound resonates in the sinuses and gives quality to sound. Tone, you know, each tone or whatever. Okay, so gotta be able to define those things, you know, and so forth. These are, you know, perfect terms to be sprinkled in the definitions, right? And then conduction of sound waves to the inner ear, starting with the external ear, and how the auricle, sometimes it's called opina, and then conducts it to the external acoustic meters. Then it gets to the tympanic membrane. Then it goes through those bones, the Malayacica steps. Then the round window. It goes on the round window, and it starts to move the perilymph on the outside. Then it moves the endolymph on the vestibular, scalar vestibuli, right? And then it moves the vestibular membrane, then the scalar, then the basilar membrane. When the basilar membrane vibrates, then it will move the hair cells organ of Corti. Okay?
I thought it went through the vocal first, and the round window was
Yeah, it's the oval window.
Oh,
Did I say round?
Yes, you did.
Oh, sorry. It's round. It's oval window, guys. Oval window. The steps vibration of the oval window. So, thank you for catching that. So that means you know. And then, of course, the round window is to dissipate, and it opens out of the scalar tympanic. Okay. All right. Okay. So just know all the parts that are conducting sound waves, and it goes in there, and it goes into the inner ear, into the cochlea. Okay. And then specifically, it's the cochlear duct. Okay, because the scalar, the cochlea is split into the scalar vestibule on the top, the cochlear duct, which is the membranous labyrinth in the middle, and then the scalar tympani on the bottom. The scalar tympani, that's where the round window opens. The scalar vestibule, that's where the oval window opens, and it vibrates with the incas. I mean, the stapes. Stapes. Okay, so generation of action potential, we talked about it. We got those teniocilia, which are shorter. One is shorter than the other. So when you bend, you know, there's a elastic protein between the hair cells, and it opens up a what kind of gates? What kind of gates? Potassium ion channels. Okay, and it's an unusual situation because potassium normally is involved in repolarization instead of depolarization. Okay, very good. So know about that. I may ask about, you know, how you generate an action potential in the ear, in the hearing, in the hair cells of the ear. Well, it may be a 2 point because it's not much to generation of an action potential. I'm not saying just bending the hairs and then we open the elastics and then potassium gets in 2 points. Neuronal pathways, of course, for hearing. through the vestibular nerve, and then goes to the vestibular nuclei of the medulla, okay, and then the thalamus and so forth. But the balance now is the neuronal pathways for balance are the ones that kind of involve the eyes and so forth. Because balance involves the sense of vision. Okay, so the two we need to know about static equilibrium, which is the definition of sensing the position of the head due to gravity. Okay, it's static, and then linear acceleration and deceleration. Okay, that's what it is. And then it's the vestibule. It's part of it, so it's got the utricle with parallel hairs to the base of the head, and the saccule, which is got vertical hairs in relation to the base of the skull. And those kind of hair cells are called maculae, right? Okay. The organ of Corti is the kind of hair cell in the cochlea for hearing. For static balance is called the maculae. That's the hair cell. Okay. But the hair cell has got the otolithic membrane on top of it. The organ of Corti is the tectorial membrane on top of it. Okay.
So utricle is horizontal?
It's parallel. Yeah, which is horizontal. Parallel to the base of the head. So it's horizontal. Okay? And then, of course, the vestibule. So everything is divided into three parts and so forth. If you ask about static balance, and then you talk about what it is, and then you define the parts that are involved. That's like a 5-point question there. When you talk about the functions, the parts involved, you describe them. The hair cells involved, 5 points. Okay, and then same thing with definition for dynamic balance, sensing movement of the head and body. Okay, so this body is moving. Okay, and then semicircular canals are doing that, and then semicircular canals have those dilations at the base called the ampulla, where the crista ambularis is located. The crista ambularis is the hair cell for dynamic balance. Okay, so there's 3 types of hair cells involved in the hearing, static, and dynamic balance. And then instead of having the otolithic membrane on top, it's got the cupula, which is a gelatinous mass on top of the hair cells. Everything has got something on top of the hair cells, you know what I'm saying? All these hair cells in the ear. So gotta be able to tell me all that, okay? And then gotta be able to tell me what it does, okay? So 5 points again. Usually I bring static or dynamic. One of those questions usually comes in. I don't know which one, but it usually does. And then here, for balance, you have to start including the cerebellum, because and then you gotta talk about the optic, the visual center as well, included in those pathways, more than the hearing, okay? Lecture 4. The heart, my favorite. Oh my God. So the heart generates all the pressure that is used to pump blood around. All right. Okay. And and then pulmonary circulation. You know what that is? Leaves the right side, goes to the lungs, picks up oxygen, comes back to the left. Okay. We know what systemic is. Leaves the left side, goes to the heart via the coronary arteries, and goes to the rest of the body, comes back to the right side. Okay? So, that's that. Location, shape, and size of the heart. You know how it is in the middle, almost. 2/3 of it is to the left, and 1/3 to the right, behind the sternum, posterior. Yeah, that's a bad word. You know, you're supposed to say posterior to the sternum, and it's anterior to the vertebral column. It's midline, it's medial to the lungs, those things. Sometimes I ask about the location of the heart, and that's an easy question. You know what I'm saying? Shape of it, about the size of your piece, and the shape is heart shaped, right? Okay. It's like an inverted triangle, really. You know what I'm saying? With the base on top and the apex on the bottom. Okay? Very good. And then the anatomy of the heart is 2 layers. The fibrous pericardium, you know the function of it, right? What does the fibrous pericardium do? Prevent overfilling and so forth, overstretching of the heart. And then the serous pericardium, which has got how many membranes? 2. Which and which? Parietal and visceral. You know, pericardium. Okay, and what's the purpose there? What's the function? Friction, guys. Serous membrane is always to reduce friction. So you gotta know those. Sometimes I might ask 2-point question. What are the 2, layers of the, the heart, membranes, and then you talk about the viscera. And then, of course, the heart wall itself it's got the epicardium, which is actually the visceral serous membrane. See what I'm saying? Because it's right on the outside, it's a direct, intimate connection with the heart. And then, of course, myocardium is the muscle. All right, and then the endocardium is the inner layer, and it's smooth. It's what appears grayish when you open the heart. You see that, and it's got in the ventricles the trabeculicani, which is the beams of flesh I talked about, and then in the atria, it's got those musculi pectinati, or pectinate muscles, if you like. Okay, so know about that, know the location of that. The atria, of course, those are what kind of chambers of the heart? They receive the receiving chambers, and ventricles are dispensing. You know, they dispense blood to the lungs and to the systemic circulation. And then external anatomy, of course, you got, of course, the vascular pericardium, but you got the coronal sulcus separating the atria from the ventricles. You got the interventricular groove separating the ventricles, right and left. So if I ask about that, you should know it because that's what you're doing in the heart, in the lab as well. And then the chambers, you know, the 2 atria, 2 ventricles, all right? Okay? And then, of course, you know, you need to know the valves, the atrioventricular valves between the atria and the ventricles, right? And what's the purpose of that? Prevent, prolapse into the atria, prevent blood flow into the atria. Semilunar valves, you know, they are located at the pulmonary and the trunk and the aorta, all right? Prevent blood flow into the ventricles, okay? You need to know where they are located and what the function of each of those valves is, you know what I'm saying? And blood flow through the heart, okay? Comes into the right side, superior and inferior vena cava, coronary sinus, right ventricle, right atrium, right ventricle, out through the pulmonary trunk, back to the left atrium, left ventricle, out through the aorta. So you gotta know that sequence in which blood vessels are channeling blood into and out of the heart. And then blood supply to the heart itself, okay, where you have the coronary artery left and right. You got the marginal on the right, the circumflex on the left, supplying the atria and the ventricles. Okay, the posterior interventricular on the right side, and the anterior interventricular artery on the left, supplying just the ventricles because they're big. All right, and then all that goes into the cardiac veins, coronary sinus. Sometimes I really ask about the left and the right side. You know how the blood moves through the heart, on the left or the right, one of the two comes usually. So, gotta know that, and then it goes through the cardiac veins and then coronary sinus, take it to the right atrium by the inner cava. Okay? So, gotta know that. And then histology, of course, you got the fibrous skeleton. This fibrous skeleton is around which valves? Atrioventricular valve and semilunar valves. Right? Yeah. It kind of anchors those valves into place, right? And it insulates. You need to know the functions of that. And then the cardiac muscle. Okay, muscle cells. You need to know the characteristics of the cardiac muscle cells. Okay, they're branched, they got intercalated discs, which have gap junctions in it to pass the, you know what I'm saying? Gotta know about all that. Okay, and then gotta know about the fibrous skeleton and what the function of the fibrous skeleton is, like insulation, electrical insulation. Okay, and anchoring the valves and things like that. So gotta know. So newborn, of course, you gotta know the changes that occur after birth. Systems that are involved, like the respiratory system, the digestive system, the cardiovascular system especially. You have all those changes that occur. Okay, and then of course fetal cardiovascular adaptations. This is what happens inside the fetus in utero when the lungs are not functioning and when the heart is not. The lungs and the liver is not functioning. So everything is centered around bypassing all that. Bypassing the digestive system and everything. So you've got the liver coming in, you got the ductus venosus connecting to the inferior vena cava. Then you've got the foramen ovale connecting to the left atrium, so that blood goes to the left side and this goes to the systemic circulatory system. And then the ductus arteriosus, which connects blood from the trunk. If blood had gone to the pulmonary trunk, it won't go to the lungs, and then it will go into the aorta and then to the body. Okay, so gotta know all those fetal cardiovascular adaptations, and then what are the changes soon after birth when the kid takes a gulp of air, not the kid, I mean the infant, okay, the neonate. neonate, okay? And then what happens? The fossa ovalis is formed after closure of the foramen ovale, things like that. The ductus venosus, ductus, venosum, okay, closes up, and then the umbilical vein becomes the round ligament of the liver, okay? The arteries, they just become the cords of the arteries and so forth, right? The ligamentum arteriosum is what used to be the ductus arteriosus, right? All that. So we gotta know all those things. Sometimes they ask about fetal cardiovascular adaptations. So we'll just quickly finish this so that we can go through this. Peripheral circulation, we know that we got the visceral, we got the systemic vessels, and the pulmonary vessels make up the peripheral circulation. And so the functions of it is to carry blood and all that stuff, carry nutrients and waste and so forth, right? So blood vessels, arteries, gotta know the different kinds. Muscular arteries, elastic arteries, and arterioles. And then finally capillaries, you gotta know that. Veins, also, you got the same thing, venules, small veins, medium veins, large veins. Okay, 3 layers as well. Okay, intima, the internal layer, middle layer, and adventitia or connective tissue on the outside. And then you gotta know the difference, of course, in the layers of the arteries, you know, the elastic and the muscular, you know, and what differences occur in these layers. Okay, and the name of it tells you what it is. You know what I'm saying? The elastic ones, of course, recoil, and these ones distribute and manage the pressure, and the arterioles, of course, and the through channels. Okay, when the pre-capillary sphincters close up, blood just goes through and it goes directly to venules. You gotta know what they are. Sometimes I'll throw it in the definitions, you know what I'm saying, through channel, or meta-arterioles, what is it? Pre-capillary sphincters, you know, what are they? They're those smooth muscle sphincters right on the junction of the arteriole and the capillary. Okay, so gotta know all those things. And what happens when you get old? Arteriosclerosis, loss of elasticity. Atherosclerosis, accumulation of plaque. And we talked about what can happen with either of those two conditions. I might ask you about it and tell me some of the symptoms that might occur with that problem. Okay, so circulation, we got that. I just need you to know the branches of the aorta. You know what I'm saying? Where you have the brachiocephalic turning into the right carotid, common carotid, and the right subclavian, and then the left common carotid and the left subclavian come out directly from the aortic arc, and then you've got the vestibular, what do you call this? The vestibular arteries going up, the transverse foramen and so forth. And so just know the branches, and then of course circle of Willis, which is formed by the anterior and posterior cerebral arteries joining the internal carotids, right? Okay, and how the basilar artery forms that. Okay, so that's it, guys. Thank you so much. We just took 5. I'll give you 5 when we start the lab. Okay, guys. Thank you so much. We'll see you in a short while. 5 past 10. Okay.